Hello guys, welcome to Ramta Solutions and welcome to your lesson on work, energy and power. Today we are continuing, as we continue with this series we will be looking at network. We have defined what is work, now we're going to define what is network. And at the end of this video, you must know what these formulas represent. Okay, so for this video, we will define what is network and how to calculate it and some few examples. So without any waste of time, let's get into it. Let's define network. Okay, so when we talk network, we basically trying to say we're looking at the sum of work of all forces acting on the object. Okay, a sum of work done, let me say that, sum of work done by all forces acting on the object. Yeah, I think that's perfect. Sum of work done by all forces acting on the object. Okay, acting on the object. Okay, so this is it. Others, you will find the another definition later that, yeah, but it's okay to leave it like this. Sum of work done by all forces acting on the object. It is very perfect. So this is where, for example, we assuming we have an object here. Let's say this object, it experiences some friction, and then it has, let's say, some applied force. Okay, let's say some applied force, and then it also experiences some normal, and then some gravity. Okay, so for you to know, you know by now how to calculate work done. You know when zero work is done, when positive work is done, and when negative work is done as well, right? So we are saying that this is the sum of work done by all forces acting on an object. So what we know, let's say we have, I will give you an example. Let's say we have, I want to call this technique 1. Okay, let's say we have, okay, maybe let me not, okay, yeah, let me say we have force here, force 1, force 2, force 2 here, force 3, and so on, right? And so on, right? So we know to find this techniques of calculating our work done, we know we can say, oh, and there's normal as well, and then there's weight. So we know for a fact that work done by gravity and Newton, and normal force will be 0, right? Especially if we are assuming that our object is moving in this direction, right? If you're assuming that our object is moving in this direction, work done by normal and gravity or weight are 0. So to find our network, we can say this is basically equal to work done by force 1 plus work done by force 2 plus work done by force 3, work done by force 4, and so on, right? And so on. So this is the first technique where you are calculating the work done by each force acting on the object, right? And you might as well just add work done by normal force and weight, of which will be 0. So don't waste your time. It's always 0. Okay? Especially if the object is moving to the right or to the left, or rather horizontally. Okay? So this is technique 1. So technique 2. Technique 2 will be, you know that you can find the net force acting on the object. So here's the object. So you can find the net force, right? What is the net force? Force 1, force 2, force 3, force 4, and so on, right? and so on. Because this force is a vector quantity, you must state, first, you must state which direction is positive. When you use this technique, state which direction is positive. Now that direction will tell you what these forces are doing. If one is moving in the same direction that you chose as positive, it will be a plus, and one, if it's moving in the opposite, it will be a minus. So you have done vector calculations in grade 11. You have an understanding of this, right? Now, having found your net force, you can therefore say net force equals, net work equals net force times the displacement. Okay? You're going to plug in the value of the net force that you obtained directly into this equation. Whether it's positive or it's negative, it does not matter. However the value is, you will still get your answer. This will tell you whether you have positive work done, zero work done, or negative work done. Okay, so these are the two techniques that you have. Okay, perfect. So now we must try examples. Okay, now we must try examples. So I'm going to try two examples. One example is on a horizontal plane, and the other will be on an inclined surface. So let's try examples. Let's say this is your object. I want to say it's moving this way, okay? I want to say it's moving this way here, and I will say its displacement is 50 meters, and then the applied force is let's say 2000 newtons, and then friction is 800 newtons. Okay, so let's say this is a car. Yeah, this is a car, right? This is a car. So yeah, this is a car. So yeah, we're saying this is a car. So now the question says to you, calculate the net force. The net work, right? The question says to you, calculate the net work. Okay, it says calculate the net work. So using technique 1, right? So it's your choice which technique you are using. Using technique 1, because I want you to get used to both techniques. You will say work done by, let's say, the engine. If this is a car, work done by the engine. So let me just call it work done by engine. It will be force applied by the engine, delta x cos theta. Now what is it? The force applied by the engine is 2000 newtons, as you can see, multiplied by, what is the displacement? It is 50 meters times cos. Where is the force headed to? It's headed in the same direction as where is the engine, the force applied by the engine headed to? It is in the same direction as the displacement. So this is 0 degrees. So it will be cos 0 degrees. So this will be 2000 times 50, it's 10, so it's 100,000. So it's 100,000, let me write it as positive. It's 100,000 joules. As you can see, the engine is doing positive work on the car, right? The engine is doing positive work on the car. So this means it's transferring energy into the car, right? Now, let's go get work done by friction. So work done by friction, let's look at it. It is F delta X cos theta. Now, friction, as you can see, it's in the opposite direction of the displacement, right? It's in the opposite direction of the displacement. So it will be 180 degrees. And we said it is 800 times the displacement is 50 times because, let's see, oh, it's in the opposite direction, so it's 180 degrees. So as usual, or rather all the times, friction is always in the opposite direction, so it'll always be cos 180 degrees. 8 times 5 is 40, so this must be 40,000, but negative, so it's negative 40,000 joules. Now, these are the only forces that are acting on the object, right? Because I couldn't include normal force and gravity. They don't do any work on the object. Now, to find net work, we will say net work is equal to work done by the engine plus work done by friction. For this example, these are the only two forces that are acting on the object. So what are they? That one was 100,000, positive 100,000, and friction was negative 40,000, right? It was negative 40,000. Our answer is therefore 60,000 joules, positive 60,000 joules. What does it mean? It means positive work is done. Now, when positive work is done, hello, now you know that what it means is that energy of the vehicle as it's moving is increasing, right? It means energy of the vehicle is increasing. Remember, our example was a vehicle, right? Okay. So, I will then proceed to look at technique number 2. So let me call it option 2. So which is technique number 2. We will say, I will choose to the left as positive, right? I will choose to the left as positive. So what I know is that F net equals force applied by the engine plus force applied by friction. Force applied by the engine is to the left, which is 2,000 newtons, and I said to the left is positive. So it'll be 2,000. And then force applied by gravity, it was to the right, which was 800. Right? Let me confirm. Yes, it was 800. So what is the net force? The net force is 1,200. Therefore, the net work is F sub net delta X. By the way, this is 1,000 newtons to the left, right? To the left. Now, what is F net? It was positive 1,200. What was the displacement? The displacement was 50 newtons. Right? It was 50. Sorry, the displacement was 50 meters. So 12,000 times 50, 12 times 5 is 60. So this will be 60,000 positive, right? Positive 60,000 joules. As you can see, positive work is done. Okay? Positive work is done. Remember, when positive work is done, it means energy is being transferred to the object. Right? In this case, energy is being transferred to the car. Okay? All right. So now we might just look at the inclined surface. Okay, we might look at the inclined surface. So let's look at it. Now, example 2. Example 2, I want to look at an inclined surface. So let's say, I will say calculate the net work. Calculate the net work. I'm going to give you a diagram. And then I will say maybe this object is going down the slope. Should I say down the slope or up? Okay, let's say it's going down the slope. Okay, let's say it's going down the slope. And then this is friction. Friction here is let's say it's 20 you know what? Yeah, let's say it's, okay, let's say friction is 15 newtons. And then let's then say, yeah, it's going down the slope. Let's say applied force is 60 newtons. Okay. And by the way, the mass of this object, I will choose 2 kilograms. And this ramp here is 3 meters. Okay, this ramp here is 3 meters. Okay, this ramp here is 3 meters. And the question says calculate the net work done to move the object to whichever point. Okay, so what we can do now is, we need to ask ourselves, first and first, you must draw a free body diagram. Okay, you must draw a free body diagram. When you draw a free body diagram, I will show you now. As usual, gravity is always perpendicular to the ground. I am not saying to the surface, I'm saying to the ground, right? It is always perpendicular to the ground. Then you have normal. Normal is always perpendicular to the surface. As you can see, the surface is inclined. By the way, let me add further information and say the angle here is 25 degrees. Right? Now, we then say, okay, since normal is perpendicular to the surface, FG parallel will also be, which must be equal to this. This is your FG parallel, right? Or FG perpendicular. This is your FG, by the way. Now, this here will be your FG parallel, right? This here will be your FG parallel, which we call FGX. And of course, the angle here is 25 degrees. Okay? The angle here is 25 degrees. So your free body will be this guy here, which is friction, and this guy here, which is, let's say, applied. Okay. All right, applied. I'm going to draw this in a new page. Okay. So the free body diagram looks like this. We say this is normal. This is FGY. And then this is normal force. This is friction. And then this is applied force. And this is weight, while this is FGX. This is your free body diagram. I prefer to draw this free body diagram as compared to this one here, where you say it is weight, it is applied force, it is friction, right? Where you say friction, applied force, and then weight, and then normal force. I don't like this one. Okay, I don't like this one because when you make your calculations, it somehow confuses you. So I prefer drawing this one. And again, even this one, others prefer drawing it like this, where you can say it is normal friction, right? It is normal friction, and then FGY, and then this is F, and then this is maybe FGX. Some prefer drawing it in this way. It's still okay to also draw it in this way. Whichever you are comfortable with, go for it. Okay? Whichever you are comfortable with, go for it. Okay? So when you look at these diagrams, there are 3 forces that are acting on the object. Okay? There are 3 forces that are acting on the object for work to be done. Those are friction, applied, and FGX. Now, to answer the question, I want us to resolve FGX. Remember, here is it, and this is 15. Is it 15 or 25? It was 25 degrees. Okay, it was 25 degrees. So this is 25 degrees. So let's remember it. So it was like this, right? So this was 25 degrees, and this one here will be your 90. We said this was your FGY, while this was your FGX, this was your weight, or FG, right? So if I were to draw it, basically I'm saying it's like this. This is FGY, this is FG, and then this is FGX, okay? And the angle here is 25 degrees, right? So I had said forces that are performing work or doing work on the object, it's FGX, friction, and this guy here, applied force, right? So to find FGX, agree with me that this side is opposite to the angle. So we will use, I want you to check it out, we will use sine 25 degrees equals FG sub F sub GX over F sub G, which is FG, right? Again, F sub GX, you know that F sub G is basically mass times gravitational acceleration. Therefore, we can say F sub GX is basically mg sine 25 degrees, right? Now, to find your net force, here, what we are going to do is we are going to say, I will use the F net. So I will say first, I will say down the slope as positive. I will take down the slope as positive. Okay? Remember, it's a vector quantity. Down the slope as positive. So what do we have? We have F net equals F plus F sub GX plus friction. What is F? It is, where is it? It was 60 newtons. It was 60 newtons. It's going down the slope. It's positive. It's fine. What is FGX? It was mg sine 25. What is m? M is mass of the object. The object is 2 kilograms. So this is 2 kilograms times 9.8 times sine 25. Let me put it in a bracket. Plus, oh, by the way, friction is going in the opposite direction. It was 15 newtons. So minus 15. What is our answer? Quickly. Okay, let me see. 60 plus open bracket 19.6. Yeah, 19.6 times sine 25 close minus 15. So our answer is 39.28332 newtons. Remember, our final answer is in 3 decimal places. So if in the middle of my calculation, I leave it in 5 decimal places, this will not affect my final answer that much. Okay? So maybe, if you like, you can just say it's 33 and so on newtons. Right? So as you can see, this is positive work. Alright, as you can see, this is positive work. Okay? Okay. Now, we can say, sorry, the force is positive, so obviously positive work will be done. So, net work equals F net delta X. What is F net? 39.2833 blah blah. Okay, we'll say 332 times, what is the distance? The length of that ramp, it was 3 meters. Here is it? It was 3 meters. Right? It was 3 meters times 3. So what is our net force? Our answer times 3. Net force, or rather our network, is 117.85 joules. This is positive work done. Okay? This is positive work done. Right? So this is it, guys, and this is how you calculate your net work. So I will see you next time when we do the work energy theorem. Okay, I will see you next time when we do the work energy theorem. So this is it, and see you next time. So bye bye.